Students, welcome back to my chemistry channel. The today topic is about uh, electrolytic conductance and electronic conductance. I would like to talk from the electrochemistry of class 12th grade. So the main topic is name is electrochemistry, class 12th grade. So which is a very important topic. And so from this, I'm going to take up electrolytic conductance, conductance, and one more. I would like to discuss about electronic conductance. In electrochemistry, so we discuss two things. One is electrolytic conductance and electronic conductance. The electronic conductance, otherwise called metallic conductance, we say. Metallic conductance due to flow of electrons through the conductor. Electronic conductance, otherwise called metallic conductance. If the conductance due to the flow of electrons from one end to another end of the conductor is said to be metallic conductors, like example copper and iron, aluminium. So good conductors, we say. There is another terminology we have, electrolytic conductance, which is otherwise called ionic conductance. Conductance, we say. So ionic conductance due to free flow of ions, so like cations and anions. Conductance due to the free flow of ions, cations, and anions through a solution, through a solution, through a solution is called ionic conductance or electrolytic conductance, we say. Mostly, electrolytic conductance follows Faraday obeying Faraday laws, we say. And in case of electronic conductance, not following the Faraday laws, not obeying and obeying the Faraday laws, we say. And very important thing we must notice is that in electrolytic conductance, we could see there is chemical change. That means we observe chemical change. We notice the chemical change due to the flow of ions due to the current. Due to the current, so we could see the chemical change after some time in the solution due to the electrolytic conductance. And in case of electronic conductance or metallic conductance, we can't notice no chemical change, no chemical change after some time. So out of these two, which is more effective means electronic conductance is more effective, and whereas electrolytic conductance for long time it is not effective. So electrolytic conductance, so useful to prepare various products, and electronic conductance useful in the circuits we say. So these are the two terms so that I would like to, and both are affected by temperature. Electrolytic conductance and electronic conductance, so affected by the temperature. When temperature increases, initially conductance increases, but when more temperature causes increasing of resistance also. So temperature can affect both electrolytic conductance and electronic conductance. When temperature increases, conductance increases, but increasing of more temperature causes also resistance, we say. Now coming to this for the discussion of conductance. So what is conductance? So how we define the conductance? Now, conductance is nothing but, if you want to understand the conductance phenomena. So if you want to understand the conductance, the first thing we should learn about conductance, given symbol is G, and it is reciprocal of, or it is inverse of the resistance. Conductance is inverse of the resistance. Then what is resistance? Resistance can be defined as ability of the substance or ability of the object or material to oppose free flow of electrons or ions is called resistance. Symbol is capital R, and the units for the resistance we say we can measure in terms of ohms. Ohms we can measure. If you understand about the resistance, then we'll understand about the conductance. Less the material offer less resistance, more is the conductance. And if the material offer more resistance, then the conductance will be less visible. So conductance is equal to 1 upon R, inverse of R we say. So now if you observe the resistance of the materials, it depends upon the nature of the material. So all the materials do not have the same resistance. For example, so copper has less resistance, conductivity is more than if you compare with chromium. And resistance depends upon the nature of the material we say. Our resistance is directly proportional to length of the material. You look into the laws of resistance. The first one is, so resistance depends upon the nature of the material, and the resistance is directly proportional to length of the material. When length increases, resistance increases, we say, and resistance is inversely proportional to cross-sectional area of the material. Cross-sectional area of the material, if you take out the proportionality constant, R is equal to rho into L upon A, where we get proportionality constant we get, which is called specific resistance we call, that is we say rho. The rho is specific resistance which is said to be constant of proportionality. So we can get the equation, resistance equation is equal to L upon A, means resistance inversely proportional to cross-sectional area of the material. The cross-sectional area increases, resistance decreases. So, and now after this, we get what is the conductance? What is a conductance? So already I told, so conductance is